Hi everyone, let's see one of the question on functional dependency. Here they have given like find functional dependency preserving or not for the relation R with attributes A, B, C, D and a set of functional dependencies as F, set of decomposed relations are D. Right? So if you would like to check whether it is functional dependency preserving or not, we have to know the logic. Like we have to find out the set of functional dependencies which are possible for the relation R1, I can call it as F1. Set of functional dependencies which are possible for R2, which I can call it as F2, and so on. For all the relations, you have to find the set of functional dependencies, I can call it as Fm for the relation Rn. And you have to find out the closure for all these, which should be equivalent to the actual relation, functional dependency is F closure. Then I can say that functional dependency is preserving. Otherwise, it is not preserving the functional dependency, right? So, if you want the clarity, you can go through the previous videos, right? So, basically, we'll take the first table. The first table is AD. We are going to find out various kind of FDs, right? So, we'll try to do the FDs which starts with A. So, for that, I am trying to go with finding A closure. If you find the A closure, you are going to get only A, right? Which means that there is no functional dependencies possible with respect to A. Similarly, if I try to find out D closure, you are going to get D. Obviously, from D I can get A, and you won't get any other thing, right? So from this you can able to write D determines A is one kind of functional dependency is possible. Okay, fine. Next, I need to go with the two level attributes. So if I find out the AD closure, you are going to get AD anyway, and you won't get anything. So this is also not comes under functional dependency possible, right? So guys, here you know it, right? So if I am going to have D determines D is possible, but it is a trivial dependency as it is going to be followed every time. Okay, fine. Similarly, you have to find out various kind of FDs for the relation BCD. If I find out various kind of FDs which starts with B, I can find out the B closure. For B, you will get only B, so I won't consider. For C, you will get only C. For D, you will get D, A. That's it. You are not going to get anything, right? So if you are able to observe here, D determines D is a trivial dependency, and D determines A is not in our relation. So I am just skipping this one, right? Next we'll go with the combination. So one combination is BC, another combination is BD, another combination is CD. Try to find out BC closure. If you find out the BC closure, you are going to get BC only. BD closure, you are going to get B, D, sorry, it should be BD as usual as like trivial dependency. BD, from D I can get A, from AB I can get C. See, observe guys. So if I find out the BD closure, you got the BDAC, which means that BD can determine AC, right? BD can determine AC. Among those, A is not in our relation, so I can just simply skip this one. I can write it as BD determines C is possible. Okay, next find out CD closure. CD closure is CD only. From D I can get A. Any other things are possible? No. So this is not possible and this is not possible, but BD determines C is possible. Similarly, if I go with the 3 level attributes, obviously we are going to get the same data minimum. So this is comes under trivial dependency. Right? These are the functional dependencies which are possible for us. Right? So now try to check whether they are going to be satisfied or not. Is AB determines CD is there? Is there any chance to get it? No. So AB determines CD is not possible from our various kind of other functional dependencies which are possible with AD as well as BCD. Right? If at least one of the functional dependencies is not satisfied, not preserving for the additional relations, then I can say that simply not FD preserving. That's it guys.